Find the length of the curve x equals 3 times the cosine of t minus cosine of 3t, y equals 3 sine of t minus the sine of 3t, as t goes from 0 to pi. No, I mean, do it. Pause. Wait, hang on. The length formula is equal to the integral from alpha to beta of the square root of dx dt squared plus dy dt squared dt. There you go. Now, pause the video, have at it. This one was tricky. Dx dt is negative 3 sine t plus 3 times the sine of 3t. Dy dt is 3 cosine t minus 3 cosine of 3t. Squaring dx dt and dy dt, forgot to underline that one there in green, we get a bunch of stuff. Combining these two, we end up with a 9 times the sine squared of t from dx dt and a 9 times the cosine squared of t from dy dt. And what we did, we had to FOIL both of these, right? 9 sine squared of t plus 9 cosine squared of t gives us 9. You can factor out the 9 and you have your Pythagorean identity. Likewise, we end up with 9 times the sine squared of 3t plus 9 times the cosine squared of 3t. Again, factoring out the 9, we get the Pythagorean identity that says that sine squared of 3t plus cosine squared of 3t is equal to 1. So we're just left with 9. For the cross terms here, we have negative 3 times 3 times the sine of t times the sine of 3t, and we're going to double that, likewise for the dy dt expression. And so we can factor out a negative 18, and we have left here, I rearranged some terms, but we have cosine of 3t times the cosine of t plus the sine of 3t times the sine of t. This may have been a good point where you get stuck. Let's help get you unstuck if that happened. Folks, cosine alpha cosine beta plus sine alpha sine beta is a difference formula for the cosine of alpha minus beta. So letting 3t be alpha and letting t be beta, all that cosine 3t, cosine t, all that stuff, with the sines as well, becomes the cosine of 2t. Now, if that unsticks you, repause it and continue on. Otherwise, I'm going to keep going. Are you ready? Ready? Here I go. Now, the cosine of 2t can be expressed as 1 minus, 2 times the sine squared of t. And distributing and simplifying is going to give us 36 times the sine squared of t. 18s will subtract out, and then 18 times 2 is where that 36 comes from. That's going to go into a square root inside of our formula for the length. So the arc length is equal to the integral from 0 to pi of the square root of 36 times the sine squared of t dt. That's really nice when we have it in this form. It's really terrible if we didn't realize how to get there. So if you need to, study the steps that we see here and recollect and finish this up. Now, the square root of 36 times the sine squared of t is equal to 6 times the sine of t, so we have that integral from 0 to pi dt. Note that the sine of t is positive or non-negative on the interval that we're talking about, and originally we were told that theta was going to go from 0 to pi. Finally, we can say that the length is equal to 6 times negative cosine of t evaluated from 0 to pi for a length of 12. Now I want to use this formula one more time. What about x equals a cosine theta, y equals a sine theta, theta from 0 to 2 pi? I'd like for you to pause now, do this work, and then draw a conclusion about what you've just done. Well, did you conclude that the universe makes sense? Here we are. dx d theta is negative a sine theta, dy d theta is a cosine theta. Squaring those, adding them together, factoring out the a squared, we have a Pythagorean identity yet again. And so into our integral, we're going to put the square root of a squared. So The length is equal to the integral from 0 to 2 pi of that square root of a squared d theta, which equals 2 pi a, assuming a is positive. And our conclusion, well, we had a circle of radius a. We found its length all the way around. This proves the formula for the circumference of a circle.